Okay, hang on tight because we're about to screech to a massive cosmic halt. Welcome to this explainer. We're diving straight into a frankly terrifying survival scenario today. Just imagine pulling back your curtains tomorrow morning, but instead of that friendly yellow orb we've known for eons, you find our sun has completely skipped 5 billion years of evolution. The entire sky is just gone, replaced by this pulsating, angry, blood-red wall of fire. Now, I know exactly what you're thinking. You probably haven't even finished your morning coffee yet. But today, we're exploring this incredibly urgent, high-stakes what-if scenario. We're going to look at the data and figure out if humanity could somehow survive an instant cosmic disaster of this scale. Because in this scenario, the inner solar system as we know it is already toast. Mercury and Venus? Poof, they've already been swallowed whole by this expanding stellar monster. It might sound a little strange to apply the words of the famous psychiatrist Carl Jung to astrophysics, right? But his quote, "When you stop carrying their pain, everything changes," actually perfectly describes our sun today. It is totally done carrying the immense weight of its own gravity, in a very literal, very incinerating way. And for us down here on Earth, well, everything is about to change in a flash. Section 1. The Science of the Swell. The OG science of our star. So right now, our medium yellow dwarf is maintaining this delicate stalemate. It's an epic internal battle between gravity trying to crush the star into a tiny point and nuclear fusion pushing outward. But tomorrow, the hydrogen fuel simply runs out. And without that outward pressure, gravity easily wins the first round by crushing the core incredibly tight. This generates immense, unthinkable heat, which ironically causes the outer layers to rapidly expand and puff up into a bloated, glowing marshmallow. It gives us a terrifying glimpse of our sun's future, looking a whole lot like the red supergiant Betelgeuse. Section 2. Earth gets air fried, a front row seat to the end of the world. Literally by breakfast time, our sky is gone. Our entire planet is completely engulfed in a stellar inferno. And here's a weird bit of cosmic irony for you. The red giant's surface is technically cooler at 3,200 degrees Celsius compared to our current sun's 5,500 degrees. But you know, that scientific distinction absolutely does not matter when you, your house, and our entire atmosphere are suddenly inside the star itself. Everything is just rapidly reduced to ashes, literally air fried, in a fraction of a second. And the sheer scale of this new sun is just monstrous. To put it into perspective, you could neatly fit 1.2 billion of our current suns inside this new red giant. The star now stretches outward roughly 4 astronomical units, meaning it spans 4 times the distance from the Earth to the old sun. It easily consumes the inner planets and catches Earth right in its fiery throat. Let's say we send a cosmic guinea pig down to the surface to investigate. We'll call him Chase. Well, Chase would tell you that the oceans are violently boiling from the top down. And because Earth's crust is 45% oxygen, the sheer overwhelming thermal radiation actively tears those molecular bonds apart. It causes the very ground beneath his feet to just crumble and vaporize. Section 3. Fleeing to the solar fringe, the great mass migration. To actually survive this, we have to drop our eons-long dependency on planet Earth and move incredibly fast. She's been our cradle, sure, but the cradle is currently sitting inside a preheated oven. As the sun exponentially expands, the habitable zone, that perfect sweet spot where liquid water can exist, gets violently pushed way, way out from Earth's orbit. We're talking about a mass migration past Saturn's moon Titan, past Pluto, reaching all the way out to distant icy dwarf planets like Sedna, sitting at 316 astronomical units. Guys, that is more than 10 times further away from the sun than Neptune currently is. And out in this newly relocated habitable zone, things get really strange. Suddenly, notoriously freezing places like Saturn's moon Titan would experience a blast of heat for the very first time in 4 billion years. The sky would turn this deep blood-red orange, the freezing methane rain would completely stop, and for a brief cosmic window of maybe a few thousand years, Titan might actually transform into a bizarre tropical paradise. Crazy, right? Section 4. Surviving the stellar sneezes, the catch to the habitable zone. Unfortunately, as with any hasty relocation, there is a pretty major catch here. Red giants are undeniably huge, and sure, they provide heat to the outer system, but they are also incredibly, violently unstable. This instability manifests as what we call stellar sneezes. These are massive surface mass ejections consisting of seething clouds of superheated plasma that just get coughed up into the solar system. We are talking about ejections billions of times the mass of anything our current sun emits today. If one of these sneezes hits a planet, it would absolutely shred whatever atmosphere it had left. Gone. So what does daily life actually look like for our survivors? Well, it means that even if humanity pulled off the impossible and made it all the way out to Pluto, we definitely wouldn't be walking around in t-shirts. Because of the intense atmospheric shredding and the super high radiation environments, we'd be forced to live entirely inside thick, pressurized domes constructed out of frozen regolith, just to survive the harsh realities of our dying star. Section 5, the ultimate cosmic reboot, finding beauty in destruction. So, how do we possibly find meaning in losing our planetary cradle, our history, and absolutely everything we have ever known in the inner solar system? Believe it or not, in all that terrifying destruction, there's a profound kind of beauty. See, when a star like our sun finally dies and sheds its outer layers, it scatters essential, heavy elements like carbon and iron back into the vastness of the universe. It literally spreads the very stuff that makes up your blood across the cosmos, providing the fundamental building blocks to create entirely new stars, new planets, and eventually, new life. Losing our ancient dependency on Earth and a stable yellow sun would force a total, uncompromising reboot for us. To survive the death of our star, humanity would just have to evolve. We'd be pushed to become a Type 2 or even a Type 3 civilization, learning to harness the energy of entire galaxies just to stay alive and keep the oxygen flowing in our regolith bunkers. The sudden expansion of our sun into a red giant is honestly perhaps the ultimate survival story. But it leaves us with one final, very provocative thought to chew on as we wrap up today's explainer. What cosmic scenario should we explore next? I mean, maybe we don't need a dying star to shake things up. Perhaps next time we look at the data on what happens if we accidentally create a black hole in a laboratory in Switzerland. Let that sink in for a minute, and I will see you in the next explainer.